Hello students, in continuation with our series on assertion and reasoning, today we'll take up alternating current. We have started with the first discussion on what are assertion and reasoning questions, what is the common mistake made by the students in solving assertion and reasoning questions, and what is the best way in which such questions should be attempted. After that, we have taken the different topics. We have started with electrostatics, followed by current electricity, then magnetic effect and magnetism, and after that we have taken electromagnetic induction. In that sequence, today we are taking alternating current. Now again, before attempting questions on assertion and reasoning, we must take first what are the different options which is given there. Like here, the first option is assertion and reason both true, and reason is the correct explanation of assertion. Second one is assertion and reason both true, but reason is not the correct explanation for assertion. Third one is assertion is true, but reason is false. And the fourth one, assertion is false and reason is true. Do check for each individual question what are the different options given, out of which you have to choose the correct option, because it may vary from question to question. So here the assertion is both AC and DC can be measured by hot wire instrument, and the reason is given hot wire instrument is based on the principle of magnetic effect of current. So let's first take the assertion statement. Both AC and DC can be measured by hot wire instrument. This is true because this is basically measuring the amount of heat produced, and in terms of that we are using those hot wire instruments. So we can measure AC as well as DC there. And the second, that is the reason part which is given, hot wire instrument is based on the principle of magnetic effect of current. This is false, because as we have just discussed that hot wire instruments are based on the principle of heating effect of current, that is the Joule's law of heating. So here assertion is true, reason is false, so that means the third option is the correct one. Let's take the next question. Capacitor blocks DC and allows AC to pass. And the reason is given, capacitive reactance is inversely proportional to frequency. First of all, let's take what is this particular statement? Capacitor blocks DC and allows AC to pass. If you take capacitive reactance, this is your 1 by omega C. And that can be written as your 1 by 2 pi Fc. This F is the frequency. For DC, this frequency value is 0. So for DC, F is 0. And if this is 0, so it is your 1 by 0, that means it is infinite. So Xc for DC will be infinite. So obviously it will block DC. Whereas for AC, if you consider whatever be its frequency there, accordingly offer some opposition to that, but it is not infinite. So it will allow AC to pass. So that means this is true. Now capacitive reactance is inversely proportional to frequency. Now you see this particular relation we have just seen, Xc is 1 by 2 pi Fc. So obviously Xc is inversely proportional to F. So this is also true. Now here assertion is true, reason is true. Now we'll have to check whether it is the first option is the correct one for this or the second one. So for that, we'll just read out assertion and reason, and in between that we'll be using because. And we'll see that whether it makes sense there or not. So here, capacitive reactance blocks DC and allows AC to pass because capacitive reactance is inversely proportional to frequency. Now this is a correct statement and it is explaining it also properly, that why it is blocking DC. Because we have seen that capacitive reactance will be infinite for DC and will have some finite value for AC. So it means the first one is the correct option. Let's take the next question. The alternating frequency lags behind the EMF by a phase angle of pi/2 when AC flows through an inductor. And reason is given that inductive reactance increases as the frequency of AC source decreases. Whenever you have a AC circuit where you have the capacitor, inductor there, and you want to find out the phase relation, you can use this word civil to find out their phase relation. Now this for this one, what we do, we take first three letters. That means it is your CIV. This C we are taking it for capacitor. And if I have to take an inductive circuit, then we'll take this VIL. And this is your for inductor. And whatever sequence it is coming, like here, if it is your CIV, so I is coming before V. So that means we can just say that in capacitive circuit, current leads voltage. Whereas if it is your inductive circuit, it is VIL we are taking. And if it is your VIL, that means voltage will be leading current there in inductive circuit. This is just to remember the phase relation there. So here you can see what is given. Alternating current lags behind voltage by a phase difference of pi/2 when it flows through inductor. So in inductor, it is the voltage which is leading. That means the current will be lagging behind. So that means this is true. And second part, if you take, that is the reason. The inductive reactance increases as the frequency of AC source decreases. Now, if you take inductive reactance, that means it is your XL. This is your omega L, and that can be written as your 2 pi FL. So here you can see that this XL is directly proportional to frequency. So that means here what is given, inductive reactance increases as frequency decreases. That means this is false. So here assertion is true, reason is false. So that means it is the third option which is the correct one. Let's take the next question. If an inductive coil is connected to DC source, the current supplied by it is I1. If the same coil is connected with an AC source of same voltage, the current is I2. Then I2 is less than I1. Now, if you have a circuit in which you have only DC source and it is connected to inductive coil, so it means it is only offering there the ohmic resistance. That means for that, it will be just its resistance. If it is an ideal inductor, we assume that its ohmic resistance is 0, but all practical inductive coils there, they will have some ohmic resistance. Apart from that, there will be the reactance there, inductive reactance. So that means for that case, Z value will be a square root of RS square plus XL square. So here, if I take current I1, suppose whatever is the voltage for DC if I am taking, in that case it is just R there. In second case, it will be your V by Z. Now you can see that Z will be definitely greater than R. And if it is such, in that case I2 will be less than I1. And that means this is true, because it is given I2 is less than I1. And reason is given, in an AC circuit, inductive coil offer more resistance. So this is also true. You have seen that it offers more resistance because it is just like the impedance there, which we are taking. So here, this assertion and reason both are true. And now let's just see that whether the first option is correct or the second one. So for that, we'll take if an inductor coil is connected to a DC source, the current supplied by it is I1. If the same coil is connected with an AC source of same voltage, the current is I2. Then I2 is less than I1 because in AC circuit, inductor coil offer more resistance. So it is explaining it properly why I2 will be less than I1. So that means the first one is the correct option. Let's now take the next question. The dimension of L by R is time. And reason is given that the time constant should be increased to reduce the rate of increase of current through a solenoid. Let's take the relation. E is your L di by dt. Of course, it will be with minus sign, but if I just take the magnitude, then we can take this one as L di by dt. That means just for the relation's sake, because we need to find out the dimension. So this is your E, this is your L, and now I'm taking delta I, delta T. So for this case, I can write E by delta I. This is your L divided by delta T. Now this term, it is your voltage by current. So dimensionally, it will represent resistance. So as it represents resistance, I can take it as R. And this term is your L. So that means this is your L and it is divided by delta T. So if I take L by R, so it means it is your delta T term. So this L by R is having a dimension that of time. So that means this is true. So dimension of L by R is time. This is correct. Now if you take this part, that time constant, that is L by R which we have taken, should be increased to reduce the rate of increase of current through a solenoid. Now this part also, if you take from where you are getting that L by R term there, L by R term is basically giving you this delta T, and delta T term if you take, it is related with this current and voltage. That means this is also true. So here, now just let's see that if assertion is true, reason is true, which option is the correct one? So the dimension of L by R is time, and because time constant should be increased to reduce the rate of increase of current through solenoid. So here, this is not explaining why the dimension of L by R should be that of time. So that means this is the second one, which is the correct option. Next question. Assertion is at resonance, the current becomes minimum in a series LCR circuit. This is false because at resonance, the impedance is minimum in a series LCR circuit. And if the impedance is minimum, then the current will be maximum. So in that case, this is your false. And at resonance, voltage and current are in phase in series LCR circuit. This is true because tan phi, if you are taking that is the phase relation between the voltage and current. In that case, what is this? It is your VL minus VC by VR. Now at resonance, voltage across inductor and that across the capacitor are equal in magnitude. So in that case, this term will be 0 divided by VR. So phi term will be 0. That means the voltage and current are in phase in series LCR circuit. So here assertion is true, but reason is false. So that means it is the fourth option, which is the correct one. Let's take the next question. When capacitive reactance is less than inductive reactance in a series LCR circuit, the voltage leads the current. Now here, if you just take the phasor diagram, this is suppose your VL, this is your VC, and this is your VR. if you take a VL greater than VC, because it is said that capacitive reactance is less than inductive reactance. So that means here this voltage is also related with the IXL and IXC. So we can take this XC is less than inductive reactance XL. So in that case, it is your VL minus VC will be there. It will have some positive value. This is your VR, and the resultant of that, if you take the net voltage, if you take it is this. Current is in the direction of the voltage across the resistor. So in that case, here, this is the angle between the voltage and current in a series LCR circuit. Now here you can easily see that this voltage will be leading current there by some angle, say phi. So this is your the statement part that the EMF leads current is true. And let's take the reason part there. The angle by which the alternating voltage leads the alternating current in series LCR circuit is given by tan phi XL minus XC by R. So this is also correct. So this is also true. Now both are true. Let's now just take the two statements together. When capacitive reactance is less than inductive reactance in a series LCR circuit, the EMF leads current. Because the angle by which the alternating voltage leads alternating current in series LCR circuit is given by tan phi, which is your XL minus XC by R. So it is explaining it properly that why the voltage will lead current there if suppose the capacitive reactance is less than inductive reactance. So that means the first one will be the correct option. Let's take now next question. An alternating current does not show any magnetic effect. Now this is not correct. Even alternating current also produces magnetic effect there. So in that case, this is your false. Alternating current changes with time. This is true. Alternating current will be the one which will be changing its magnitude and direction periodically with time. So in that case, this is true. In this case, assertion is false, but reason is true. So that means this is the fourth one, which is the correct option. Let's take the next question. A step-up transformer converts input low AC voltage to output high AC voltage. Now, if it is a step-up transformer changes the voltage there from low to high. So that means this is your true. Number of turns in the secondary coil will be more than number of turns in the primary in step-up transformer. So obviously in that case, the output voltage will be more than the input voltage. And that is what we call them as the step-up transformer. And the reason part is given that it violates the law of conservation of energy. Now this is false. Remember that law of conservation of energy is a universal law. That means it is applicable for all cases there. Here, of course, in transformer also you may get there that input power in ideal case should be equal to the output power. But if suppose we find that in practical transformers there output power will be less than the input power, that is not violating law of conservation of energy, because here the energy will be transformed to some other form, maybe in the form of heat or some other losses will be there. That is why the output power is less than input power. So it is not violating the law of conservation of energy. So in this case, assertion is true, reason is false. So that means the third one is the correct option. Let's take the last question in this discussion. Assertion is principle of operation of AC generator is electromagnetic induction. So this is true. an AC generator works on the principle of electromagnetic induction. You are basically converting mechanical energy into electrical energy of alternating nature. And in this one, you are basically changing the magnetic flux, and due to which the induced current is developed there. So it is based on the principle of electromagnetic induction. And second part is resistance offered by inductor for AC is 0. If I consider an ideal inductor, in that case, there will be no ohmic resistance of that one. So in that particular case, as it is the word resistance, so obviously this is true. And inductor will offer impedance for the practical cases there. So in that case, it will have the resistance as well as the inductive reactance there. And if I assume that ohmic resistance is not there, in that case, it will be the inductive reactance which will be offered to AC. So here assertion is true, reason is true, and now let's just take that the two statements together. The principle of operation of AC generator is electromagnetic induction because the resistance offered by inductor for AC is 0. So this is not explaining the principle of operation of AC generator. So in this particular case, this is the second one is the correct one. So this was our discussion on few questions on alternating current. We'll take a few more questions of assertion and reason on alternating current in next discussion.